In this lesson, we'll recap on the different concepts in binomial theorem. We'll be finding the n factorial, using the binomial coefficients n choose r, performing a full binomial expansion, and most importantly, using the general term to find the coefficients and a specific term. It starts with factorial. N factorial is defined by the multiplication of all the whole numbers from 1 to n together. First, we will evaluate 6 factorial. 6 factorial will be equals to the multiplication of all the whole numbers from 6 to 1. And when you press your calculator, you'll get 720. You can also use the factorial function in your calculator by pressing 6 and the factorial button followed by equal, and that will give you 720. Next, we'll look at binomial coefficients. N choose r is equals to n factorial over the multiplication of r factorial and n minus r factorial. We'll now evaluate 9 choose 3. 9 choose 3 from the formula given earlier will be 9 factorial over 3 factorial, and 9 minus 3 will be 6. So we'll have 6 factorial. And we know that 9 factorial is the multiplication of all the whole numbers from 9 to 1. 3 factorial will be the multiplication of all the whole number from 3 to 1. And 6 factorial will be the multiplication of all the whole number from 6 to 1. When you press your calculator, you'll get 84. Now you'll realize that the numerator and the denominator has 6 factorial in it. So let's look at what is remaining here. You will notice that 9 choose 3. For the numerator, there will only be 3 numbers, and the denominator will also have 3 numbers. So you will multiply the numerator from 9 to 7. You'll do it 3 times. And the denominator, you will multiply upwards from 1 to 3. In other words, you will multiply the numerator from 9 downwards 3 times, and the denominator you will start from 1 upwards 3 times, and that will give you 84. You can easily check your answers using the calculator and choose R function. In order to do that, you first press 9 and you press shift and the divide button to get the n choose R function. And since we need 9 choose 3, we will have to press 3 followed by the equal sign. And this will give us 9 choose 3 equals to 84. If you recall how we evaluated 9 choose 3, we'll use the same method to express n choose 2 as a fraction in terms of n. We will start with n and we'll multiply 2 times. For the denominator, we'll start with 1 and we'll also multiply 2 times. The numerator will multiply downwards. The denominator will multiply upwards. So it will be n multiplying downwards to the next whole number, which is n minus 1. And the denominator will start with 1 multiplying upwards, which is 2. So simplifying, we'll have n times n minus 1 over 2. In the same way, we can express n choose 3 as a fraction in terms of n. This time we'll do it 3 times. The numerator will go downwards 3 times, and the denominator starting from 1 will go upwards 3 times. Simplifying, that will give us n multiplied by n minus 1 multiplied by n minus 2 over 6. Next, we'll carry out a binomial expansion using the binomial expansion formula. To expand 2x minus 3 over x power 4, we will use the binomial expansion formula. To do that, you just need to look at the general term. Since the value of n is 4, we'll start with 4 choose 0, multiply by the a term, followed by the b term. We'll fill in the power towards the end. following this number at the bottom here. So the power is 0. The other power will be 4 minus 0. Next, we will have 4 choose 1, followed by the A term, followed by the B term, and the power towards the end will be this number 1. And the other power will be 4 minus 1. Next, we will have 4 choose 2, followed by the A term and the B term. The power towards the end will be this number here, which is the 2, and the other power will be 4 minus 2. Next, we'll have 4 choose 3, followed by the A term, the B term, and the power will follow this R value here, which is 3. And the other power will be 4 minus 3. Lastly, we'll have 4 choose 4, the A term, the B term, the power 4, and the other power will be 4 minus 4. 4 choose 0 is 1. So we have 1 multiplied by 2x power 4. We will always take out the negative 1 first. So we have negative 1 power 0 and 3 over x power 0. To simplify the next term, we will have 4 choose 1, which is 4, multiplied by 2x cubed. We take out the negative 1 power 1 and the remaining 3 over x power 1. We will have 4 choose 2, which is 6, multiplied by 2x squared. We'll take out the negative 1 square and we'll write down 3 over x squared. Next, we have 4 choose 3, which is 4, multiplied by 2x power 1. We'll take out the negative 1 cube and we'll write down 3 over x cubed. Lastly, 4 choose 4 is 1, so we have 1 multiplied by 2x power 0. Take out the negative 1 power 4 and write down the remaining 3 over x power 4. We will let all the terms with power 0 to be 1, so you can kind of ignore them. And we'll simplify the rest of the terms in this order. We will have the sign, which is the plus and minus, followed by the coefficients, which are the numbers, the constants, and followed by the x terms. So the sign for the first term here is actually positive. The coefficient will be 2 power 4, which is 16. And the x term will be x power 4. Next, the sign will be negative 1 power 1, so the sign is negative. The coefficient will be 4 multiplied by 2 cubed multiplied by 3. That will give us 96. For the x term, we have x cubed over x, so that will be x squared. Next, the sign here, negative 1 square will be positive. 6 multiplied by 2 square multiplied by 3 square, that will give us 216. X square over x square will give us 1. So there will be no x term here. Next, let's look at the sign again. The sign here will be a negative sign. 4 multiplied by 2 multiplied by 3 cubed. That will give us 216. For the x term, we have x over x cubed. So x over x cubed will have 1 over x squared. Lastly, the sign here will be a positive sign. So we will have 3 power 4 for the coefficients, which is 81. And the x term will only be x power 4 at the denominator. So what do you observe about the sign? When there's a negative in the middle here, your sign will be alternating from plus to minus to plus to minus to plus and so on. Lastly, we have come to the most important concepts in this chapter, which is the general term. The general term is used to find a specific term in the binomial expansion so that you do not have to expand everything, which will take up a lot of time. Let's look at this same example here, but this time around we are asked to find specific terms, like the second term, the term independent of x, and we are asked to find coefficients and also terms in 1 over x power 4. So instead of expanding every single term, we will use the general term to help us to find each of the following. To find a specific term, we will use the general term t r plus 1 equals to n choose r a power n minus r b power r. To find the second term, it will be t2. So for t2, the r value is actually 1. So we'll start r equals to 1 into the general term here. That will give us 4 choose 1 because the power n here is 4. Then we'll write down the a term. We'll write down the b term. We'll write down the power towards the end, which is the r value here. And the other power will be 4 minus 1. Again, we will simplify according to sign, coefficients, and x term. So for the sign will be negative 1 power 1. The coefficient will be all the constant terms, 4 choose 1, 2 power 3, and 3 power 1. We'll follow the order from left to right. And the x term will be x cubed, and here we have 1 over x. Simplifying again, we'll have negative. The coefficient will be 96, and they are color-coded. X cubed over x will be x squared. So this will be the second term. We do not need to expand out every single term. All we need to do is use the general term to find what we need. Next, to find a specific term such as the term independent of x, we'll use the general term here. The objective is actually to find the value of r first so that we know exactly which term will have the term independent of x. So we know that n value will be 4, and we'll put r as r here. The a term will be 2x. The b term will be negative 3 over x. Recall that this power here will be this value at the bottom. So this power here will be r, and the other power will be 4 minus r. We'll simplify in this order here, which is the sign, the coefficient, and the x term, and we'll do it from left to right. So for the sign, we have negative 1 power r. For the coefficient, we have 4 choose r, 2 power 4 minus r, and 3 power r. The coefficient will be the non-x term. For the x term, we will have x power 4 minus r multiplied by 1 over x power r. We will simplify the x term here further using the law of indices. So this will give us x power 4 minus 2r. Because when you have the power at the denominator, you will minus the power when given the same base. So this is what we will have after we simplify a little bit further. For the term independent of x, this power here should be equals to 0. So 4 minus 2r equals to 0, and that will give us 2r equals to 4, which will lead to r equals to 2. Now we can substitute this r equals to 2 value here. The negative 1 will be power 2. Then here we have 4 choose 2, 2 power 4 minus 2, 3 power 2, x power 4 minus 2 times 2. Simplifying, we will have a positive sign. This will give us 216 here. And since x power 0 equals to 1, we will no longer have any x term here. So the term independent of x is 216. The next specific term that we are looking for will be the coefficient of x power negative 2. We'll use the general term, And likewise, our objective is to find the value of r here. For the coefficient of x to the power of negative 2, this power here must be equals to negative 2. So 4 minus 2r will be equals to negative 2. That will give us r equals to 3. We'll substitute back into this expression here, and it will give us this general term here with r equals to 3. Simplifying, we'll have negative 216 x power negative 2. Now, there's something wrong with this answer here because the question asking us to find the coefficients and not the term. So we just need to have the coefficient, which will mean that we will remove all the x term here as our final answer. Lastly, to find the term in 1 over x power 4, we'll use the general term once again. This time round, we'll let the power here be equals to negative 4 because 1 over x power 4 is x power negative 4. So 4 minus 2r equals to negative 4. Solving for r, we'll have r equals to 4. And we'll substitute it back into this expression here. That will give us this general term. Simplifying, we will have 84 x power negative 4. So that will give us the term in 1 over x power 4. And that's all for the recapitulation.